In test number 9, I used an X-Tech voltmeter and an amp meter to measure the input to the gap generator prior to the power supply. Well, later on I decided that it would be better if I used the amp probe and the volt probe from the oscilloscope itself. So that's what I did. So let's take a look at the test results. Set the magnification to 125 and we'll scroll over here a little bit. And here we are. The test results, like I said, input volts and amps measured before the power supply. We had 73.86 watts over unity. Now that's with removing the last half of the input. Let's look at the power supply. Now, at the point of taking the test, it said there was 36 volts and 9 amps being supplied, according to the power supply. So let's look at the scope. And here it is. The number 1, the yellow, is the volts input, AC volts. And number 2 is the blue, amps input. Over here, channel 2, cycle RMS, says 4.80 amps and a question mark. Number 3, the purple, is the voltage output. And number 4, the green, is the amps output. The gap generator, with no moving parts, has a cycle time of 60 milliseconds. And you can see here that I have the scope set in time to 10 milliseconds. So that means each little square here is 10 milliseconds long. The cycle starts right here at this arrow. And you count over 10, 20, 30, 40, 50, 60. That's 60 milliseconds. And that's the end of one cycle. Now I only supply input power to the gap generator with no moving parts for 30 milliseconds, half the cycle, the first half. 10, 20, 30. So this is the only time right in here that power is being applied to the gap generator. So I can remove all of this over here, the second half, the 30 second half milliseconds. And that's what I do. Bring that up there, you can get a little better view of it. 10, 20, 30, 40, 50, 60 milliseconds. But note how flat, there's a lot of flat line here on the amperage input. I mean, it's at 0 for most of the cycle. And that's kind of strange. Normally in AC, the voltage is going to follow, or the amperage is going to follow the voltage, kind of like this. But not so in this case. Well, let's look at where I removed the last half. Let's go down to the start of the cycle at 0. And right here it is, start of the cycle, 0 in time. So let's scroll on down to 30 milliseconds, which is half of the cycle. Right here. Half the cycle, 30 milliseconds. So the next reading is where I set the input volts to 0 and the input amps to 0. And I did that through the remaining portion of the cycle, the last half. And right here it is, the end of the cycle. Anyway, that's what the test looked like, measuring the input prior to the power supply. And note it's still over unity, and by quite a bit. This will be the last test. (125) magnification. Okay, now this test was done exactly the same as the previous test you just saw. Input volts and amps measured before the power supply. The watts over unity here was 26.06. Now the watts over unity on the previous test you just saw was 73.86. Now why is that? Well, I think I know. Here is the oscilloscope screen of this test. The voltage input before the power supply is number 1, which is yellow. The input amps before the power supply is number 2, the blue. And note here on channel 2, the blue, it says 4.00 amps question mark. Now that same thing is so on the previous test, if you notice. Now, I think that's the problem. It has a hard time interpreting this as AC, because you can see, anyone that's familiar with an oscilloscope can see that the amperage isn't following the voltage just like it normally does. Let's look at it a little tighter here. Here you can get a little clearer view. See how flat the amperage is for a big portion of the cycle here. It's right on 0. And I think that's why it's got the question mark here. So anyway, the gap generator with no moving parts, each cycle is 60 milliseconds long. So I have this screen in 10 milliseconds, time-wise. Each one of these little squares is 10 milliseconds. The cycle starts right here. So 10, 20, 30, 40, 50, 60 milliseconds. That's one cycle from here to here. Now the first half of the cycle is the only time that power is being applied to the gap generator with no moving parts. So all this over here on this side, I remove from the reading in order to get a true reading. And I'll just show you that right now. I'm going to scroll down here till we come to the start of that cycle. It'll be at 0 milliseconds. Yeah, here's the start of the cycle, 0 milliseconds. Now we'll scroll on down here a little bit till we come to 30 milliseconds. We'll get there. Here it is. Here's 30 milliseconds, half of the cycle. So this is where I put 0 in for the voltage and 0 in for the amperage. And I do that all the way to the end of the cycle, which is at 60 milliseconds. Right here, 60 milliseconds. And anyway, I just kind of wanted to bring this to the attention that this way of checking this prior to the power supply, there's a little variation there, and I think it's because it has a hard time reading it. But this thing is reading power being supplied to the power supply and the gap generator, and it's still over unity. So that's the point I'm trying to make here.